Assalamualaikum everyone. Welcome to lecture number 4. So today we are going to cover the topic IC fabrication. In the last class, we already covered the silicon processing from the sand till the silicon ingot and also silicon wafer. So the next step will be IC fabrication and also the what we call industrial packaging. So the picture here showing the wafer with the IC fabrication on the surface. So each square represent the one IC chip. Okay. So on this one IC chip, there are millions of what we call um, circuit on it. Okay. So the picture below showing on the circuit being printed on the IC chip. So this is depending on the fabrication architecture, the individual device, maybe diode, transistor, capacitor, resistor, and etc. on the IC chip. So if you look into the chart here showing the miniaturization progress, we will see that the things become smaller and smaller from the starting of the this MEMS technology. Okay, so when it becomes smaller, the process also become more complicated and much more difficult to be fabricated. Now let us look into the IC design process. Now, the first thing first that we have to do in order to design the IC, of course, we have to design the circuit itself. Okay, so usually CAD file is used to design the circuit, and the circuit must be designed according to the customer requirement and what are the functions. And of course, we need to know the electrical circuit is functional. It cannot be designed just like that. Okay, so the dimension of the circuit can be scaled according to the actual size up to 1:1, or it can be bigger. Okay, so that one depending on the process that you're going to use for printing on the IC board. um, for example, there will be lithography, a lot of type of lithography later that you can see. Some of them require scale of 1:1 mass, and some of them you can use a bigger one, so that later the light can be used to focus to make it into smaller circuit. The second step in order to design the IC is photo mask making. After the circuit is already designed, you have to mask the circuit. Okay, you have to fabricate the mask in order to transfer the design circuit pattern to the surface of the wafer. This process of transfer will be done through the photolithography or UV lithography process. So sometimes negative pattern will depend on the resist type lah. Okay, so can need to be done so that it suit the required circuit use. Okay, so in the process of making photo mask making, opaque chrome metal film is used to prevent the light to go through the pattern. Okay, so that if you can see in the picture here, so this is the design. Let's say this is the design of the circuit that we want to print on the IC chip. So other part that we don't want it to be the circuit will be covered with the chrome metal film, so that when we want to transfer all the circuit to the IC, this part will not be printed. Okay, because we don't want this to be printed, this area. Okay, so that it will block the light. Okay, the light only will print the circuit on the IC. Okay, so transparent glass region allow light to go through. So meaning usually this material that used to print this mask is glass. Okay, so if you can see here, they use glass and then they print the circuit on this area, and the area that not supposed to be circuit will be covered with the chrome metal film. The fabrication of the mask in order to create the IC design also requires separate lithography process. So this one we will see in the next in the future. We are going to look into the lithography processes. And commonly several masks is required for us to do the pattern on the wafer. So let's say for example, for one for one circuit you might need more than one. Let's say they have mask 1, mask 2, mask 3, because there are layer of circuit usually involved in the process of the IC circuit in fabrication on the wafer. Before the wafer is going to be printed with the circuit, the wafer must go through some preparation also. The first process for the preparation of the SI wafer will be outside growth on the wafer. Okay, so this is will act as the insulating dielectric layer, which is the silica on the SI wafer. So if you can see into the picture, so this is the silicon. Okay, so then there will be oxide layer placed into the area here. Okay, so this layer will provide insulation between the conducting layer that will be fabricated. Okay, and then it also provide insulation between conducting layer and underlying SI wafer substrate. So this one you will see later how does it work. Okay, other than that, it also act as a supplementary masking material during fabrication operation, and also to protect the SI surface from any damage or anything. Okay, so there are two methods to provide the oxide growth on the SI wafer. There are thermal oxidation and also CVD. Okay, we're going to look into these two process. The first one that we are going to look into is thermal oxidation. So how does the thermal oxidation is performed? So if you can see here the chamber here, the quartz tube here. So all the wafer will be placed vertically on the inside the quartz carrier inside here. So then at atmospheric pressure with the temperature around 750 to 1150 degrees Celsius, the oxygen and also H2 gases will go through the chamber here into the quartz tube here, and then there will be a reaction because silica, when you expose it at a certain temperature with the water or with the oxygen and hydrogen, there will be oxidation process happen. So in here, the silicon that is not covered, which is the exposed area, will react with oxygen and hydrogen to form the SiO2 and also water. Okay, so the thickness of the oxide layer will stop further chemical reaction, and the layer thickness usually less than 1000 atomic thickness. The next process that can be used for the oxidation process is chemical vapor decomposition, or CVD. Okay, so this process usually employed when we need thicker dioxide insulation. Okay, so this one also employed in between fabrication step if the oxide layer is required to be grown. So different with thermal oxidation, silicon from external source is used here. Previously, we just used the silicon and also the oxygen and also hydrogen to react and then create the layer, right? So as for this one, since we want a thicker dioxide layer, we need to supply more silicon to the chamber. Okay, so in here, if you can see, there are several methods inside here that can be used. In here, if you can see, the first one, SiH4 with the oxygen at temperature 400 to 450 degrees Celsius is supplied into the chamber. And then you can also use SiH4 with the NO2 at temperature 650 to 750 degrees Celsius, or it can use also SiH4 plus carbon dioxide and hydrogen at 850 to 950 degrees Celsius. So then the silicon SiH4 will react with the gases to leave the silicon on silicon oxide on this layer, and the other things will react become the gas and then leave the chamber after finishing. After the oxide layer is being what we call as created on the surface of the wafer, the next step is to put the resist coating on the Si wafer. Okay, so photoresist is spin coated on the Si wafer. So if you can see in the picture here, so this is the solution for the photoresist. Okay, so you place it on the what we call the silicon wafer that's already gone through the oxidation process, and then it will be spin, okay, so that it can be distribute what we call the thickness will be uniform, and it also does not require a very thick what we call thick layer. Okay, so that's why the excess one will leave the area on the surface here. So thickness of the coating will be depending on the viscosity of the resist, meaning that how viscous is the what we call the resist. If the resist is very high in viscosity, then maybe the layer will be very thin. Okay, so if the viscosity is low, meaning it's very thick, then thicker layer will live on the area here on the surface. And also it also depending on the RPM of the spinning chuck. If this one is rotated very fast, then maybe less resist will remain on the surface. Okay, so this is showing the wafer after the initial oxidation. After that, there will be photoresist will be placed on the wafer. So there are 3 layers before we start with any printing of the circuit. There are supposed to be these 3, at least 3 minimum layer like this one: photoresist, oxide, and also the wafer. There are 2 types of photoresist. One is positive and another one is negative photoresist. Now let us look into the positive photoresist first. For the photoresist, when the photoresist is exposed to the UV light, it will become soluble. So for example, like here, we have resist and then silicon oxide and also the silicon wafer. Let's say this is the mask before we do the printing. So this mask will be exposed with the UV light. Okay, so from the top there will be UV light. So let's say this is the metal mask metal plating, meaning the chrome one is already placed inside here. So what happened is, if it is positive resist, all the clear part that exposed to the light, the UV light, will become soluble. Okay, so meaning that it will not live inside here. The part that not exposed to the light will remain on the SiO2 layer. Okay, so in the end, when we do the cleaning and everything, when the only the this part only will remain. Okay, so you have to remind that positive, when it is exposed, it's soluble. Okay, exposed to the light, it becomes soluble. As for the negative, so this one is inverse of the positive. Okay, so when it is exposed to the UV light, it will become polymerized. So for example here, if you can see, when this area is the glass one, so it will be exposed to the UV, right? So when it is exposed to the UV light, this area will become polymerized, meaning it's hardened, and this area will be soluble. The one that not covered with the not exposed to the UV light will become soluble. So in the end, you will be able to see this area that remain when you use the negative photoresist. So this is a quiz. If you look into the left and also the right, which one is using the positive photoresist and which one is using the negative photoresist? Okay, I leave this to you to answer. Okay, so if you don't If you still didn't get it, so meaning that you don't understand what is positive and negative photoresist. After the photoresist is already applied, before we do any printing, we have to do the soft bake. So wafer will be heated in 2 thermal cycle. First, it depends on the resist type, what is the type of material that used for the resist. Typically, it will be around 90 to 100 degrees Celsius for 20 minutes in convection oven. Okay, so this is the convection oven. And another one is through on the hot plate like this one, at the temperature of 75 to 85 degrees Celsius for 45 seconds. Okay, so this one, the baking is used first to evaporate the resist solvent, meaning that they might not be what we call dry on the surface yet. So then if we do the baking, then it will evaporate the solvent itself, so that the remaining solvent will be what we call um, will be on the surface. Okay, so it also increase the density of the resist coating and also promote better adhesion with the SI wafer. So that's the end of part 1. See you in the part 2. Thank you.